you ever wondered what happens when you mix certain materials? For example, baking soda and vinegar. Salt and water. Mentos and Diet Coke. Now, does that make you nervous when you are blending paints, applying makeup, or mixing ingredients in the kitchen? Now, how can people predict these reactions? Over the centuries, scientists realized that a certain combination of elements form compounds. Other elements rarely form compounds. The periodic table of elements is one way of organizing elements by their chemical behaviors. The purpose of this speech is to inform the audience of the components of their periodic table. Although you will not become an expert during this presentation, you will be able to recognize the interactions in your next science class. My name is Cupp, and I plan to attend Henderson State University to obtain a chemistry degree. I have taken many major math and science classes, and I have obtained science awards in chemistry. To understand the modern periodic table, you must understand its history. Let's go into the kitchen, your home's chemistry lab. Throughout centuries, there were many developments of a periodic table. The Greeks used the four elements, earth, wind, water, and fire. However, in 1869, there was a new race to develop a periodic table. Russian chemist Dmitri Mendeleev emphasized chemical properties. German chemist Lothar Meyers emphasized physical properties. Both scientists used periodicity, which is regular periodic repetition. Mendeleev created a table where elements arranged by increasing atomic weight. Elements with similar chemical properties appeared in the same column. He arranged the 62 known elements into his early table. He included blank spaces for missing elements. As our understanding of chemistry improved over the centuries, the periodic table evolved. Here's the modern periodic table, which is controlled by the periodic law. The periodic law states that the properties of the elements are periodic functions of their atomic numbers. Here's what that means. Arranging elements by increasing atomic numbers, we periodically see similar chemical and physical properties. Vertical columns are called groups or families. Horizontal rows are called periods. Think of the periodic table like a spiral staircase or like a parking garage. Start your way at the top and wind your way down. Elements in the same group have similar chemical and physical properties. However, they are generally to the next larger size as you move down the column. Elements have properties that change slightly as you move across the table. This occurs because of the additional electrons. Reading from left to right, the first column excluding hydrogen is the alkali metals, including lithium, sodium, and potassium. The second column is the alkaline earth metals, including calcium and barium. The last column on the far right are the noble gases, or rare gases. These were once known as the inert gases because they rarely interact with other chemicals. To the left of the noble gases is the halogens, or the salt formers. Scientists use these locations to predict chemical reactions. For example, chlorine is a halogen, one place to the left of the noble gases. Sodium is an alkali metal, one place to the right of the noble gases. Therefore, NaCl, or table salt, is a common product in chemical reaction. Generally, the lower left side of the table represents the metals. The upper right represents the nonmetals, and these two are separated by the metalloids. That's an overview of the periodic table, but it's only the tip of the iceberg. Hopefully this is making more sense to you. Let's review to make sure that you have the major concepts. Groups or families are called vertical columns. Periods are the horizontal rows, And moving from lower left to upper right, the elements are classified metals, metalloids, and non-metals. Thank you for your time, and remember this when you are mixing chemicals.